Hello students, welcome back to the classroom point. In our previous class, we have discussed about the molarity. So molarity, definition, problems we solved. And we know that in that molarity, 1 molar solution is known as 1M solution. If it is a semi-molar solution, so semi-molar solution can be written as m/2 solution or else 1/2 m solution or else 0.5 m solution. Similarly, decimolar solution deci stands for 10. So 1/10 m solution or else m/10 solution or 0.1 m solution, and centimolar solution is equals to 1/100 m solution or else m divided by 100 solution or 0.01 m solution, and these also can be written as 5 into 10 power minus 1 m solution or else 10 power minus 1 m solution here, and this is 10 power minus 2 m solution. So this type of concepts we discussed in our previous class. Now in our today's class, we are going to discuss the molality and mole fraction, which are the other concentration terms apart from the molarity. Now let's begin the class. Molality. It is denoted by the letter small m. So molality stands for the number of moles of solute present in 1 kg of solvent is called its molality. The main difference between the molarity and molality is, in case of molarity, we take the volume of solution in liters. And in case of molality, we don't take the solution, but we take this only solvent. That too, mass of the solvent, not the volume of the solvent. So now, using this definition, let us derive the formula. Molality is equals to number of moles of solute. So number of moles of solute present in 1 kg of solvent. So I am taking the mass of the solvent as W. So mass of the solvent in kg. So from this we can write down the units of the molality. N units are moles. Kg is the unit of the mass, so that moles per kg. If you elaborate this term here, so we get that molality equals to number of moles of the solute can be written as weight of solute divided by molecular weight of solute into 1 divided by mass of the solvent in kg. But most of the time, the mass of the solvent is given in the grams. We know that 1 kg is equals to 1000 grams. So by multiplying this, we will get this mass of the solvent can be taken in the grams. So here molality equals to weight of solute divided by molecular weight of solute into 1000 divided by mass of the solvent now in grams. So if we observe all these terms, the terms involved in the formula of the molality, weight of solute is there, mass, molecular mass, mass of the solvent, constant value. So all these are mass terms. Mass do not change with the change of the temperature, but volume changes. So that we can understand that the molality is independent of temperature. Molality is independent of temperature, and since it is independent of the temperature, molality gives accurate answers in comparison to the molarity. But while solving the problems, molarity is more convenient than the molality. That's why most of the questions in their solutions we use the molarity instead of the molality. But for dilute solutions, extreme dilute solutions, we can consider the molarity is equals to molality. So here we can add one more point, that for extreme dilute solutions, molality is equal to the molarity. So now let us solve some questions here about the molality and its terms also. Here mass of the solvent is given. Sometimes they don't give the mass of the solvent, but they give the density and all these values. We know that density of solvent is equals to mass of solvent divided by volume of solvent at that particular temperature. So that here mass of solvent is equals to density of solvent into volume of solvent. So instead of the mass of the solvent, we can use the density into volume of the solvent, so that this formula can be modified to some extent as that molarity equals to weight of solute divided by molecular weight of solute into 1000 divided by density of solvent into volume of solvent. Here density and volume, the values must be taken in the here grams per milliliters, here volume also in the milliliters, so that the final value could be in the grams, because per milliliters or cubic centimeters cancel out. Why? Because here we already converted the term into the grams. Now let us see here what other terminology helps in identifying the questions. Like that, here we have seen that molar, semi-molar, centimolar solutions. In case of the molality also similar terms are there, but here we use the not molar but we use the molal. So molal solution, if they don't mention anything but simply mention molal solution, means here you can consider the one small m, one molal solution. And next one, semi-molar solution. Semi always stands for the half. So 1 by 2m or m divided by 2 or 0.5 m or 5 into 10 power minus 1 m solution. Decimolar solution. Decade stands for 10. So the deci also stands for the 10. But here 1 by 10. 1 by 10 m or else m divided by 10 or 0.1 m or 10 power minus 1 m solution. Centimolar solution is equals to 1 by 100 m solution or m divided by 100 or 0.01 m or 10 power minus 2 m solution is called as the centimolar solution. Now let us see one or two questions based on the molality. So example question here is, find the molality of 4 grams of NaOH in 104 grams of solution. So here mass of the solution is given. So let us try to solve this question. See, mass of the solution is given. Mass of the solution is equals to mass of solvent plus mass of solute. We want the mass of the solvent because here mass of the solvent to be taken. So here mass of the solvent is equals to mass of the solution minus mass of the solute. Mass of the solution is given as 104 grams, so that you take the 104. Mass of the solute is given as the 4 grams, so that the value is equals to 100 grams of solvent is present. Now use this formula to solve the equation. Molality equals to mass of the solute is 4 grams and molecular mass of NaOH is 40 into 1000 divided by 100 grams of the solvent. So here it goes 10 times, 1000 by 1000 cancel out. So finally the answer is equals to 1 m. So like this we can use the molality concept, and there is one more relation, that is molality is also equals to solubility of the particular salt into 10 divided by molecular weight of salt. So if the solubility of the salt is given at a particular temperature, so solubility of the salt multiplied with 10 and divided with its molecular mass also gives the molality. So this is about the molality. Now let's begin the another concentration term, mole fraction. Mole fraction is represented by the symbol chi. It is not x, but it is a chi. So what is mole fraction? It clearly says that mole, there is no change in the term, that is mole only. Fraction means ratio. So the ratio of the moles present in a solution is called as the mole fraction. Let us see here, the definition of the mole fraction is, it is the ratio between the number of moles of a component to the total number of moles of all the components in the given solution. So that is what called as the mole fraction. Now let us consider there is a solution. Imagine the solution is having two components. Component A and component B is present. Let us consider the component A is a solute, component B is a solvent. Together they are making the solution homogeneous mixture, that is called a solution. Let us consider the number of moles of A present here in the solution is Na, whereas for B it is number of moles equals to B, and total number of moles present in the solution Na plus Nb. Then if you want what is the ratio of only mole fraction of the moles of this A, that means mole fraction of A is equals to number of moles of A divided by total number of moles. Total number of moles means here Na divided by Na plus Nb. If you would like to calculate what is the mole fraction of the B, then number of moles of the B divided by total number of moles, or else number of moles of A divided by number of moles of A plus number of moles of the B. If third component is also present, namely C, then total number of moles becomes Na plus Nb plus Nc. Here also Na plus Nb plus Nc, Na plus Np plus Nc. Like this we have to take it. But we also know that number of moles, weight by molecular weight. So mass terms are involved. So here all are number of moles, mass terms only involved. And you can take the number and volume also, they get cancel out. So that here in the mole fraction, if you see mole fraction of anything, it is the mole by mole, ratio of the moles. Moles of the particular component by total number of moles. Moles cancel out. That's why mole fraction has no units. It has no units. At the same time, since all mass terms are involved and it is independent of the temperature. So it is independent of temperature. Whether temperature increases or decreases, mole fraction and the earlier term molality, they don't change. Now, let us see here in this particular composition of the solution, two components are there, A and B are there. So, sum of the mole fractions of all the components of a solution is always equals to unity. Unity stands for 100% or 1. So, mole fraction of A plus mole fraction of the B is equals to 1. If 3 are there, mole fraction of A plus mole fraction of the B plus the third one, mole fraction of the C, together is also equals to again 1. So, whatever the number, for example, 100 number of components are present in the solution, even though 100 are present, but adding the mole fractions of all these components, finally their value must be equals to only 1. That stands for the only 100%. Now, if you want to calculate mole fraction of A here, you can do the 1 minus mole fraction of the B. In the similarly, mole fraction of the B also equals to 1 minus mole fraction of the A can be done. So, let us take one question here. Find the mole fraction of both C2H5OH and water if 2 moles of ethyl alcohol is dissolved in 8 moles of water. So here we can solve the question. See, number of moles of ethyl alcohol is equals to 2 moles. Number of moles of the water is equals to 8 moles. Total number of moles equals to 2 plus 8 is equals to 10. Then they are asking the number of mole fraction of the ethyl alcohol. So here mole fraction of the ethyl alcohol equals to number of moles of ethyl alcohol divided by total number of moles. Number of moles of ethyl alcohol given as 2, so that 2 by 10 is equals to 0.2. So mole fraction of the water is equals to 8 divided by 10. That's why its value equals to 0.8. Or else sum of the mole fractions. We know that mole fraction of the ethyl alcohol plus mole fraction of the water is equals to 1. As you know the mole fraction of the ethyl alcohol, mole fraction of the water equals to 1 minus mole fraction of the ethyl alcohol. So 1 minus 0.2 equals to 0.8. Like this also we can easily derive the value. So let us see one more question regarding the mole fraction. Find the mole fraction of 4 grams of NaOH dissolved in 180 grams of water. So this is the value given. So now let us solve this. Number of moles of sodium hydroxide NaOH is equals to weight by molecular weight. Molecular mass is 40, so that it is 1 by 10. Value equals to 0.1. And number of moles of water, weight 180, molecular mass is 18. That value is equals to 10. And total number of moles, 0.1 plus 10 is equals to 10.1. Now they are asking us to calculate the mole fraction of NaOH. So mole fraction of NaOH is equals to number of moles of NaOH divided by total number of moles. Number of moles of NaOH given as 0.1 divided by total number of moles given as 10.1. So let us solve this. 0.1 divided by 10.1, the value equals to 0.0099. So 0.0099 is the mole fraction of the NaOH. That means this is a very dilute solution because the moles of the solute in the given solvent is almost negligible value is there. So for this type of the solutions, you can consider the what I said earlier was molarity is equals to molality. I hope you find this video is informative purpose, and if you like these videos, and please do share with this one with your friends, and send your doubts to the classroompoint@gmail.com. Thank you one and all.